Hey guys, so I was grading your first balancing equations assignment with the slideshow, and I noticed a lot of us didn't turn it in, and those of us that did turn it in were struggling a little bit. So I just wanted to do some more examples with you today on this assignment so that you don't have to do it all on your own. So I'll try to do a few so that you don't have to do all 10, but you do need to be practicing these on your own. Because the only way to really master balancing equations is going to be for you guys to practice. That's what it's all about, is practice, practice, practice. Unfortunately, or fortunately, honestly, these are not things that you can Google. These are things you have to know how to do. So if you're not practicing, you're going to struggle a little bit. So I have your worksheet here on the left, and then in my second window, I have a chart that's going to help me when we're doing these examples. For you guys, the best way to do it is to write it out, right? To write it on a separate sheet of paper. But technology helps me go a little bit quicker on this video. So if you wanted to pull up a chart like in Google Drive, you could do that if it helps you that way. But honestly, writing it by hand is going to be the best way for you to do it. And then just putting your answers into the document to upload to Canvas. Okay, so let's go ahead and get started. Remember, our law of conservation of mass states that matter cannot be created or destroyed. So whatever elements we have on the left-hand side of the equation, we're going to have on our right. These first two columns here are going to be for my reactants, so what's on the left, and then these two columns here are going to be for my products on the right. Okay, so the first thing I'm going to do is write out my elements. So I can see I have a magnesium, I have a fluorine, I've got a lithium, I've got a carbon, and I've got an oxygen on my left-hand side. So those are my reactants. And of course, because these are on the left-hand side, they're also going to have to be on the right-hand side. They can't go anywhere. They can change. You see they rearranged a little bit, but they can't go anywhere. Okay? Now let's count our atoms. This is why counting atoms is so important. We have to be able to tell how many are in each compound in the equation. Okay? Magnesium, he has no subscript, so he's 1. Because if there's no subscript, we're just assuming it's 1. Fluorine has a 2 subscript on the left, so he's 2. Lithium has that 2 subscript, 2. Carbon has no subscript, so it's 1. And then oxygen has a 3 subscript, so it's 3. Okay? Now let's look on the right-hand side. So we're coming over to our products now. Magnesium, no subscript, so it's 1. Fluorine, no subscript because it's 1. Lithium, no subscript, 1. Carbon, no subscript, 1. And then oxygen does have that 3 subscript. Okay? So right off the bat, I can see that my magnesium is balanced, my carbon is balanced, and my oxygens are balanced. So my fluorine and my lithium, these guys are out of whack. Okay, so fluorine and lithium is 2 on my left-hand side, and they're only 1 on my right-hand side. So seeing that those are the only 2 out of balance, I'm going to initially start by trying to get those balanced first, and then if things get kind of thrown off, I can work from there. Okay, but I know if lithium and fluorine both need 2, I can start off by putting a 2 coefficient for my lithium fluoride. Okay. And it's important when we're balancing these equations that we always go back and update our atoms as we add coefficients. Remember, we cannot manipulate subscripts. The only thing that we can change are the coefficients. So every time we do that, we need to make sure we're updating our atoms. So now that we have a 2 coefficient here, we're going to have 2 fluorine and 2 lithium. And now this is a balanced equation. The magnesiums are equal, the fluorine is equal, the lithium is equal, the carbon and the oxygens, they all equal out. So the only thing we had to do for this first one was put a 2 in front of that lithium fluoride in our products, okay? So the thing about these is they can seem overwhelming at first. Like first looking at this equation, there's a lot going on, there's a lot of elements involved. But in the end, all we had to do was add 1 coefficient. So it was actually pretty simple. If you guys work it out and write the elements down and work through them and make sure you change your atoms as you go, it should be pretty easy, and especially if you continue to practice, because that's going to be the biggest thing is practicing. Now, on a test or a quiz, you won't see any coefficients here. Like if it's assumed 1, you won't see a 1, right? So the proper way to write that is just to leave it blank. However, if you're a visual person and it helps you, you could write a 1 here for each of these. But just know that's not really the correct way to write it. And you won't see it like that on like a test or a quiz. Okay, so let's do the next one. Oh, and I will say before I move forward, coefficients. So if you see the coefficients here, like we put a coefficient here, these can never be decimals. I saw that in a couple people's assignment I was grading. They always have to be a whole number. So remember, if you get to the end and it's not balancing, you can double everything and start again, but you cannot have a decimal. So all the coefficients always have to be whole numbers. Okay, so let's do number 2. So we have a phosphorus, an oxygen on our left, and of course a phosphorus and an oxygen on our right. On the left-hand side, we've got 4 phosphorus, again because his subscript is 4. We've got 2 oxygen, and then we've got 2 phosphorus, and we have 3 oxygen. Okay, so here I can already see this is not balanced. So the first thing I'm going to do is try to balance out my phosphorus. So I've got 2 on the left, or 4 on the left, excuse me, and 2 on the right. So if I want to get my phosphorus on my right balanced, I know I'm going to have to multiply by at least 2. Okay, because I need to be 2 times 2 is 4 to get up to that 4 for the phosphorus on the left. So I'm going to put a 2 right here. And again, we know we want to change our atoms as we go. So since we've put this 2 coefficient here, my phosphorus on my right is now going to be 4. And my oxygen is now going to be 6. Because remember, whatever coefficient you put in front of the compound affects all of the elements in that compound. So 2 times 2 is 4. 2 times 3 is 6. So now our phosphorus is balanced, but our oxygen is unbalanced. So we have 6 on the right and only 2 on the left. Well, thankfully for us, we can add a coefficient to get this oxygen to 6, right? So I'm going to go ahead and we need to ask ourselves, what times 2 is 6, right? Or 6 divided by 2 is 3. Okay, so we can put a 3 coefficient there because remember, we can put coefficients, we just can't change subscripts. Remember, the coefficients go in front and the subscripts go behind. Change coefficients but not subscripts. So now, because we put that 3 coefficient there, we have 6 oxygen. So 4 and 4, 6 and 6, this is balanced, okay? And again, I'm going to leave this one blank because we didn't have to put a coefficient with that first phosphorus. All right, let's do the third one. So I'm just going to go ahead and start listing my elements. We have rubidium, nitrogen, oxygen, we have beryllium, and we have fluorine. And again, we know that all of these are also going to be on the right-hand side, so I'm just going to paste it over. I've got 1 rubidium because he's got an assumed 1 subscript, 1 nitrogen, 3 oxygen, 1 beryllium, 2 fluorine. Okay, remember when you're looking at elements, this might be throwing some people off too. We know rubidium is its own element because it's a capital and a lowercase. Remember, elements are either 1 capital letter or a capital and a lowercase. So I can tell just by looking here that we've got 3 elements there. Okay, now let's look on the right hand side. Oh, here we've got a polyatomic and we have a subscript in parentheses. Remember, when we're counting atoms, that subscript outside the parentheses only applies to the atoms in the parentheses. So this 2 is going to apply to the nitrogen and the oxygen, but not the beryllium. So we have 1 beryllium. We have 2 nitrogen because this nitrogen applies to here. So 2 times 1, because he's got an assumed 1 subscript. 2 times 1 is 2. 2 times 3 is 6, so we have 6 oxygen. Then we have 1 rubidium, 1 fluorine, okay? So out the gate, I can see that this is definitely not a balanced equation. So I'm just going to pick a place to start, and we're going to start working our way through. So I can see that my nitrogens are unbalanced, as well as my oxygens and my fluorine. So I'm just going to go ahead and start with my nitrogen. So on my left-hand side, I have a 1, and on my right-hand side, I have a 2. So I'm going to go ahead and try to get my nitrogen on the left up, and by doing that, I'm going to have to put a 2 coefficient in front of that compound with that nitrogen, okay? So now that I've done that, I got to rework, right? So I'm going to do, now have 2 rubidium, because 2 times 1 is 2. I'll now have 2 nitrogen, and I will have 6 oxygen. And now we've gotten our oxygens balanced by doing that, and we've got our nitrogens balanced, but our rubidium is now unbalanced, okay? So I'm going to try to go ahead and fix that as well. So since I have 2 on the left, I'm going to go ahead and come over here and put a 2 on the right as well. So that 2 now will give me 2 rubidium, and it will give me 2 fluorine, which will also solve my problem with my unbalanced fluorines. Okay, so now we've got 2 rubidium, 2 nitrogen, 6 oxygen, 1 beryllium, and 2 fluorine. And that, my friends, is absolutely a balanced equation. And I'm going to try to do one more really quick before my timer runs out so that you guys can get one more example. All right, let's do the next one really quick. We've got silver, nitrogen, oxygen, and copper. And of course, we'll have all those on the right-hand side as well. All right, so let's look. We've got 1 silver, 1 nitrogen, 3 oxygen, 1 copper. On the right-hand side, we've got 1 copper, because again, the copper is outside the parentheses. So this subscript with the 2 is only going to apply to the nitrogen and the oxygen. So we've got 1 copper, 1 silver. Sorry, I put the copper number, but the copper and the silver are both 1. 1 copper, 1 silver. Then we have 2 nitrogen and 6 oxygen, okay? So let's go ahead and try to balance this out. So just like before, I'm going to try to get my numbers up. We can't go down, we can only go up. So I'm going to look for those elements that are higher and try to match those numbers, okay? So right off the bat here, I see I have 2 nitrogens on the right, so I'm going to go ahead and try to get my nitrogens up on the left, okay? And a lot of times when you do this, everything else will fall into place. So I'm going to have to put a 2 coefficient there, because that's where my nitrogen is on my left. So again, we got to keep up and make sure we are adjusting as we go. This will then turn into 2 silver, 2 nitrogen, and 6 oxygen, which now we've got balanced nitrogens, balanced coppers, and balanced oxygens, but my silver here is still unbalanced. So I'm going to come over here. We've got 1 silver, but we need 2. To solve that, we'll put a 2 coefficient, which will give us then 2 silvers. Okay, so now we've got 2 silver, 2 nitrogen, 6 oxygen, and 1 copper. And that, again, my friends, is a balanced equation. So those are the first 4. You could use a table like this if this helps, if that helps you kind of keep everything, you know, neat and tidy. Or you can write it out. I honestly recommend writing it out because it helps you remember. The biggest thing, write all your elements first. Count all of your atoms. Be sure to pay attention if you have any, especially like parentheses and then the subscripts. Remember, they only apply to the elements within the parentheses. And then always start by moving your way upwards, right? We can't go down, we can't change subscripts, but we can always add coefficients. So like if you're noticing that there are elements that need to be bumped up, start there and then work your way around. Okay, I hope these 4 were helpful. That means that just leave 6 that you guys have to do on your own. And honestly, you need to practice those 6 so that you have a good understanding of how to balance equations. Let me know if you have questions, and I'll see you guys in your next lesson.